Volvo just jumped into a 800-volt game, faster charging, thinner cables, and less heat. But what does that actually mean for the real drivers and the grid? The EX60 isn't just a new Volvo, it's the company's step into a next-generation electric architecture that promises huge gains in charging speed and efficiency. In this video, we'll explain the architecture, show the real numbers you can expect at the charger, and spell out the trade-offs, infrastructure needs, compatibility with older chargers, and what this means for battery life and future EV design. Stay with me and I'll give you the practical takeaway you can use when shopping for a long-range EV or planning your road trips. Hello everyone, I'm Shayan, an engineer specialized in electric vehicle development. What Volvo announced and why it matters. Volvo says the EX60 is built on its new SPA3 architecture with an 800-volt electrical system and a structural cell-to-body pack. The headline: the EX60 can add roughly 168 to 173 miles of range in about 10 minutes on a 400 kilowatt station. That's a coffee stop fast. That car is also designed to accept very high peak charging power when conditions and chargers allow. On paper, Volvo lists battery options and ambitious range targets for different trims and emphasizes a long battery warranty and vehicle-to-grid capabilities. Those specs show Volvo aiming not only for range and speed, but for a full system that supports long-term ownership. Why 800 volts? The physics made it simple. Power equals voltage times current. If you want more power without doubling current, raise voltage. That's the core reason automakers move from 400 volt systems toward 800 volt. You can deliver the same kilowatt with roughly half the current. Lower current reduces resistive losses in wiring and connectors, which means less wasted heat and the ability to use thinner cabling in some places. In practical terms, that improves charging efficiency, reduces thermal stress on the system, and lets the car accept very high power for longer before overheating becomes the limiter. Technical reviews and industry analysis back this point. Higher voltage reduces cable losses and cooling demands, improving overall system efficiency. Real charger numbers you'll care about. Volvo's public specs and launch material highlight fast charge capability on high-power DC stations. The EX60's claim of adding around 170 miles in 10 minutes uses a 400 kilowatt charger baseline, which is in the top tier of public chargers today. Real conditions, battery temperature, state of charge, and charger health determine how close you get to the number. Volvo also notes fallback behavior. When 800-volt chargers aren't available, the EX60 can accept 400-volt charging with a built-in booster. Though at reduced peak rates, for example up to 120 kilowatt on some 400-volt stations, the fallback is crucial for the real-world usability while 800-volt chargers proliferate. Where the speeds come from, sustained power, not just the headline peaks. High headline kilowatt matters, but what truly shortens stop time is the area under the charging curve. Sustained power over the session. Because 800 volt lets current be lower for the same power. Components run cooler and you can maintain higher sustained power longer. That's why an 800 volt car can sometimes add more range in the same minute window than a 400 volt car, even if both connect to the same high power charger. Lab and industry papers show lower current and better thermal margins translate into longer plateau periods at high kilowatt before tapering. Here's the catch: 800-volt cars need compatible DC chargers to show their full speed. Right now, the public fast charger network is mostly 400-volt in practice, with a growing but limited number of 800-volt capable sites. That means many owners will see the EX60 perform slower at many public chargers, until networks add more high-voltage hardware. Volvo helps by including a DC-DC booster so the EX60 can charge from 400-volt DC stations, but at a reduced peak rates, often capped around 120 kilowatts. That's a pragmatic compromise, but it lowers the coffee stop promise where infrastructure lacks. Cost complexity and thermal management. Designing an 800-volt system raises engineering and cost questions. Power electronics, contactors, and insulation standards need reworking for higher voltages. Cooling for inverters and battery thermal systems still matters. 800 volt helps reduce some heat from wiring. But batteries still generate heat during very fast charge and discharge events. Advanced wide bandgap semiconductors like SiC and robust thermal systems are required to get full benefits, and that raises parts and manufacturing costs at the least initially. Industry analysis point out that while 800 volt reduces some costs, lighter harnesses, smaller cables, early adopters pay more for SiC and higher grade components. What this means for everyday drivers. Practical examples. If you drive mostly locally and charge at home overnight, the upside is modest. 800 volt doesn't change overnight level to charging. The meaningful benefits show up on the road trips or for owners who depend on many fast charging top-ups. Example scenario, road trip top-up. On an 800 volt capable 400 kilowatt station, Volvo claims you can add 170 miles in 10 minutes under ideal conditions. In real life, with preconditioned battery and moderate ambient temperatures, that kind of session can cut a 30 to 40 minute stop down to something much closer to a coffee break. Transformation for long haul travel. Example scenario, mixed infrastructure. Plug the EX60 into a common 400 volt DC charger without the high voltage feed or into a standard 150 kilowatt charger. The car will still charge, but it will be constrained to lower power envelope or fallback booster rates. So the trip savings compared with a 400 volt car may be smaller. That's the reality for years as fast charger networks evolve. Higher voltage alone doesn't magically improve battery lifetime. Chemistry and thermal control do most of the work. However, because 800 volt reduces current for a given power, it tends to reduce the heating in conductors and connectors, which lowers system heat stress. That can help with longevity if charging behavior is managed sensibly. Research and industry reviews say 800 volt can mitigate some thermal stresses, but the battery chemistry and active thermal management remain decisive factors for long-term degradation. 800 volt becomes a clear winner in three cases. When the network has enough 800 volt chargers so you actually hit the high power curve often, when you frequently need high sustained charge power, when manufacturers pair 800 volt with a robust thermal system and silicon carbide or SiC power electronics so the car can sustain high power without throttling. If those boxes are checked, you get shorter stops, less heat loss to wiring and connectors, and potentially improve charging efficiency on high power runs. For drivers who mainly charge at home, the benefit is future-proofing more than immediate everyday gains. Bottom line for buyers and planners. Volvo EX60 and its 800 volt SPA3 architecture are significant. They push fast charging closer to an actual quick stop instead of a long break. And they bring system-level efficiency improvements that matter at highway speeds during the repeated fast charge cycles. But the real payoff depends on the charger network and how manufacturers tune thermal and power systems. For most drivers today, the best practical approach is charge at home overnight for daily miles, precondition before DC fast charging to maximize the high power window, and when road tripping, plan routes that list 800 volt capable stations to get the full benefit. Volvo's fallback support for 400 volt stations via booster keeps the EX60 usable everywhere now, while letting owners tap top speeds when the infrastructure and conditions allow. That pragmatic approach means the EX60 is fast today and will get faster as the network upgrades. If you want to learn more about battery management system inside electric vehicles, how they calculate your state of charge, state of health, you can click on the link in the description. Thank you.